Good evening, all. Um, Welcome to the problem solving session 6 for the course unit 1. And I will be the beings from IIT and I am Yogendra Narayan, a PMR research scholar who will be handling this problem solving session for this course. So, uh, these sessions, to give a brief background for these sessions. So these problem solving sessions are being conducted in order to make the learners proficient in the concepts that has been taught in a particular course in a particular week by making them solve the numerical questions and conceptual questions based on the contents of the week, thereby preparing them for the NPTEL final examinations, which is further useful in the candidates' preparation for several competitive examinations as well as in really in professional industrial life. So as far as week 6 is concerned, so I would also like to clarify that due to some uh, unprecedented errors last week, the session was not recorded properly. So I will be recording this session once again and I will be uploading it. Um, Most probably by Monday evening. So these sessions are usually on Saturdays from 5 p.m. to 7 p.m. Unless otherwise specified or um, unless otherwise a rescheduling is specified. So I hope the rescheduling will not be required further into this course. So as far as this week is concerned, we have been introduced to the topic of we will be solving some questions related to effective stresses, computation of effective stresses, pour water pressures, and total stresses. Followed by we will be introducing the concept of compaction and how it is relevant and how the laboratory compaction, the difference between laboratory and field compactions and its relevancy in the practice. Um, in the that's all day-to-day practice of geotechnical engineering. So going into this session, the fifth question. The water table is located at the depth of 3 meters below the ground surface in a deposit of sand 1 meter thick. So the guide to solving this type of problems is always trying to convert the text into figures. So let this be the ground surface. The deposit of sand 1 meter thick. The sand is saturated above the water table. Total unit weight of sand is 20 kN per meter. To calculate the total pressure or water pressure and effective pressure at depth 0 through 7 from the ground surface and plot their distribution. Right. So now let this be to bottom. And now coming to this, the water table is located at the depth of this depth entire India's 11 meters. And at the depth of 3 meters, we have water table. This is completely saturated, which is given. So we need a 0 3 and the depth of 7 plus external extension. Now let us compute the dot specific at 0 the total space is going to be 0 and at 3 it is going to be three, 60 divided by 60 and local pressure, flow water pressure and effective pressures are both 0, 3, 7 and this is at 0, this is at 3. Total stresses 20 million level, 20 into 7 is 30. You have to into 11. Coming to flow water pressure, which is going to be 0 here. Flow water pressure is 0 here, 0 here. That's meter with unit weight of water be 10 kilometer. meter cube. So now it is going to be 10 into 7 is 70. Now that's 1 meters is 1 ton. Now effective stress is going to be 60 and 40 million 70 is going to be 1 ton. So the total stress at 0 is 0, 4 water pressure at 0 is 0, effective stress at 0 is 0. And at 3 meters, the total stress is 60, the 4 water pressure is 0, means the effective stress is 60. At 7 meters, the total stress is 140, which is since the sand is completely saturated, it's just 20 into 7, which is 140, and 4 water pressure is 7 into 10, sorry, is 3 is going to be 1. Minutes 50 and that 220 minutes is going to be 140. So the total stress at 7 meters is 140. This is 3 to 7 meters, which is 4 meters, 4 into 10 40. And this is going to be 100, which is 140 minus 40, which is 100. So at this point, it is 220. 4 water pressure is at 11 meters is water column is 8 meters. It's going to be 80, and this is 220 minus 80 is going to be 140. So this is how the effective stress, pore water pressure, and total stresses are calculated. The always the easier way is for solving this problem is convert the text to the text to the figure, and then plot it in a graphical form for better understanding. Right, so that will always be helpful for you in approaching the problem. So the layer of clay extends from ground level up to a depth of 6 meters and overlays at 6 meter thick sand level. The water table is at 6 meters below the ground level. The unit weights of saturated sand and unsaturated clay layer For 20 kilometers per meter and 16 kilometers per meter respectively. A surcharge load of 50 kilometers per meter square is acting on the ground level for a long duration. Determine the following key for them, just diagram. This is where the ground level. Yes, this is the surcharge. Other methods, which and now effective stress at 3 meters below ground level. So the pore water pressure is going to be zero here. Now for A, sigma dash is equal to sigma minus U. So U is going to be zero since the water level is of zero. The sigma is going to be 50 surcharge plus 16 into 3 is 3 meters is equal to 98, right? The pore water pressure is going to be zero. Surcharge is going to exist is going to exert pressure at each point below the ground level. So that will be a constant load which is 50 kilonewton per meter and it is independent of pressure. And now remaining thing is going to be the overburden, which varies with the depth and has a unit weight of 16 kilonewton per meter, which is gamma into Z. So we get 28 kP. Pore water pressure at 6 meter below the ground level. So here we are given that water table is at 6 meter below the ground level. So the pore water pressure at 6 meters. You 6 meters going to be 0. because there is no water pressure that is exerted at the water column, and the unsaturated layer is because of the heat due to the refrigeration. So which is for assumption. So this is the output of the pressure. When we are not being given any information about the capillary wells which is happening, so hence we also cannot compute the negative pore pressure that is acting on the clay layer above it due to the partial saturation. Alright, so with this available information, it's always better to go by the conventional route where we assume no capillary raises present, and means the pore pressure is zero at the point of groundwater level. And the third question is total stress at 6 meters below the ground level. So sigma is equal to 50 plus 16 into it is going to be like 6 is 96 by 50 plus 146 50. Right? And the pore water stress at 12 meters below ground level. So this is done. This is done. This is pore water pressure at 12 meters below ground level. You at 12 meters. It's going to be, let us assume the unit weight of water is 10 kilometers per meter cube. So it starts from 6 and it extends up to 12, which gives us a column of around 6 meters. Then the forward pressure going to be 60 kPa. Effective stress at 12 meters below ground level. 12 meters below ground level, so that's going to be what's going to be quite a long repetition. So sigma is equal to 50 plus 10 6 plus 2 into 6. It will be 146 plus 120 and be 266. Pore water pressure is going to be 60 kPa. And the effective stress is going to be 266 minus 60, which is going to be 206 kg. That is A, this is B, this is B, and B, and this is B. And the effective stress according to the ground values is 206. You are making the like this. Doubts? Coming to the next question, the, sur- the surface of a saturated bed deposit is located permanently below the body of water. Surface of a saturated bed deposit is located permanently below the body of water. Laboratory tests have indicated that the average natural water content of the fresh hot pond water and specific gravity of soil solids is 2.7. What is the vertical effective stress at a depth of 10.5 meters below the top of the level? Furthermore, an excavation is made by dredging for keeping the water level unchanged. What depth of clay must be removed to reduce the effective stress at the same point by 50 kPa? Alright, now let us try to figure convert it into a figure. Now we have pointed 0.5 meters. Now this week, let's what this week is 1%. Cheers. Mhm. Sad. So drama factors going to be missed and six around 25 and 32. All right. Now, computing aspects specifically and prefix as concepts and diagrams finance and improvements that will have that will be the chances and tendencies to take control in finance. Now, some this is the effective stress at this point now. Now, what you're saying is some amount of flow has to be removed. So this is the layer one. Now, this is going to be a new layer. Let this be bits. Let this be small bits. And let this be 10.5 small bits. Let, let me remove this point. The questions. This and this. That. Now, same point, sigma dash is going to be 29.8 to 12. X plus plus 10.5 there. So this is the total stress. Now, for water pressure is going to be 10 into H plus H plus 10 into 10.5 other that is going to cancel, this is going to cancel. Going to be that will be these points also. This going to be so this factor is this going to be so now 21.6 7 21.8 divided by 7.6 is going to be which is equal to 10.5 minus 3.9 so the depth of clay, which is depth of clay that has to be removed, which is denoted by H, is approximately 6.58 meters. We have to remove 6.58 meters to reduce the effective stress by 50%. Which is initially we have 79.8. About to reduce it by 50%, that is to bring it to 29.8. Okay, here we need to remove 6.58 meters of clay and it will be automatically replaced with water since the water column is not going to change, the depth of water column is not going to change it. Hope this is clear. Just rewrite that. So good evening. Am I audible? Hello, am I audible?
Yes, sir.
Yeah, so can you just introduce yourself and where are you from and what is your background and everything?
Sir, myself, my name is Sumant Kore, sir.
Okay,
I am doing for working professional as a residential engineer in Rails Consultancy, sir.
okay,
And I am now working as a residential engineer, sir, uh, in construction of ROB, sir, National Highway, sir.
okay. So you are
Yes, sir.
based in Mumbai.
Yes, sir. No, sir, I'm in indoor, sir, now. I am
Okay.
pursuing my MTech in indoor IIT, sir.
Oh, fine. Okay.
Completed, sir, there. Then I joined here, sir. Yes, sir. Okay,
Okay,
sir.
good.
Okay, sir.
Yeah. So, I,
Yes,
so the session has been recorded. So the previous uh, questions which have been solved, you can look at it after it has been uploaded. in the NPTEL portal of viewers of the course.
Yes,
So
yes, sir.
from this, we can try to come next onwards. We can try to solve it together. All right.
Okay, sir. Yes,
Right.
sir. Okay, sir.
So these sessions, you know the timings, right? It is from 5 to 7 on every
5 to
Saturdays.
7. Yes, sir. Yes, sir.
Yeah. So I'll just be right back in 2 to 3 minutes. We'll
Okay,
continue
sir.
after that.
Okay, sir. Excellent.
Continue. Am I audible now?
Yes, sir. Audible, sir.
Mm. So coming to the next question. Calculate the maximum dry unit weight of a soil mass having a Void's ratio of 0.7 and a specific gravity of soil solids is 2.65 if the optimum moisture content is 17%. So calculate the maximum dry unit weight, gamma D max. How will you calculate it? How will you calculate? Any idea? Any idea? Hello?
Yes, sir. Gamma D is G into gamma W divided by 1 plus C, sir. Wide ratio. That
Okay.
formula we are going to calculate, sir.
Okay.
Answer I am telling you, sir.
Yeah, yeah, sure.
Gamma W 9.82 kilonewton I am taken, sir. I am
Okay.
calculating, sir. 1 minute, sir. Calculator by calculator. Sir. 2.65 to 9.81.
You can take 10 or 10. It is better.
Yes, sir.
You will get the value for.
55.27. 15.20 kilonewton per cubic meter is coming, sir.
Yeah, 15.29 by using 9.8.
Kilonewton per ton. Yes, sir. Yes, sir.
You can calculate with 10 once using 10.
Sir, using
10 as unit weight of water.
10, sir.
You have used 9.81, right? So
Yes, yes, sir.
try with 10 once.
E value 10, sir.
No, no, not E value. Gamma W is
10. 10 kilonewton, sir.
yeah, 10 kilonewton per meter cube.
Okay, sir. 15.59 coming, sir.
Yeah, that's what it is. It will be 15.9.
Kilo, kilonewton 15.588 RA, something 15.5 kilonewton per cubic meter, sir.
Yeah, so we can round it up to 15.6 kilonewton per
60.
meter.
Yes, sir.
So how did we calculate gamma D is equal to gamma W G by 1 plus V.
E, sir. Wide ratio.
Yeah. So it is going to be 10 into 2.65.
Divided by 1 plus 0.70, sir.
1 plus zero point 0.7 is going to be 1.7. So that
1.7.
will give us a value of 15 point, approximately 15.59. 15.59 kilonewton per meter cube. It is approximately 15 point 15.6. But so the right option is option D.
D, sir.
So,
Yes, sir.
any doubts?
No, sir.
Okay. So coming to the next question,
Yes,
in a
sir.
compaction test, the weight of hammer considered is 3 kg instead of 2.6 kg. And the number
Mhm.
of compaction layers are 5 instead of 3. What will be the new compaction energy transfer to the soil? How will you calculate it?
1 minute, sir. I am calculating, sir. What questions given, sir? Number of blows. Sir.
How will you calculate compaction energy?
Energy, sir, calculating number of blows divided by volume, sir, I think, sir.
That is fine, but um, this total energy transferred is, do you know the basis of how it is calculated?
Then I think, sir, this is given old and new. Hammer consider 3 kg instead of 2.6 kg, sir.
Yeah,
Then old is 2.6 kg. Then new before that 2.6 kg they are used, sir. Then 3 kg used, sir.
no, we are
Then
not, it is only new compaction energy, right? You did not calculate the difference. You can just use the new values of hammer weight and number of layers and then calculate it. So, how will you calculate it? The compaction energy is going to be m g h into number of blows into number of layers. So,
yes, sir.
right, it is the potential energy which is getting transferred to the compaction, which you are giving as a compaction energy, right? So you are
Yes, sir.
making the hammer fall from a particular height. So that potential energy of the hammer is getting transferred to the soil as compaction energy. So the now the mass of uh, hammer, weight of hammer is going to be 3 into 9.81 into, so H is going to be 0.31. Let us consider standard factor only. Into number of blows is going to be 25 and this is going to be 5. How much you are getting?
So 3 into 9.81 into 0.31 into 5 into 5. 1140 comes, sir,
Yeah, so 1140 per meter cube.
per meter. Sir.
All right,
Sir. 140 kilojoules per meter cube, sir.
kilojoule per meter cube.
Meter cube, sir. Yes, sir.
We are getting, so the right option is going to be
B,
option
sir.
B.
B.
Any doubts?
No, sir. Okay, sir. From MGH into H into NG. Okay, sir.
Yeah.
MGH. Okay, sir.
So because mgh is for one blow, so you are given
One blow.
25 blows. So
Yes, sir. MGH for one blow.
yeah, so 25 blows and the number of layers is 3. So you are
3,
giving
sir.
25 blows, 25 blows, 25 blows.
Yes,
So
sir.
that's why we have to calculate the total potential energy which is getting transferred to the compaction energy. So
Yes,
that's
sir.
why we multiply it with the number of blows and the number of layers total. Right?
Yes, sir.
Coming to the next question. Out of the following methodologies, which one is used for compacting coarse grain soil? So you are working in highways, you must be well versed with this compaction. So you will be uh, which is more suitable for coarse grain soils? Compaction techniques. So the most effective way for compacting coarse grain soil is vibrations. Right? Sheepwood rollers is for place essentially. So but the most suitable form of for compacting coarse grain soil is using vibrations. So coming to the next, any doubts? Any doubts?
No, sir.
Yeah.
Continue, sir.
Yeah. So I have a quick. I need to. There is an emergency. So
Okay, sir.
what can you do is I will project the earlier questions. You can try to solve this. Okay.
Okay, sir.
I will be back in a minute.
Okay, sir.
Since
Okay, sir. Okay, sir.
quickly this one. So just a minute.
Okay,
I
sir.
will share this screen again.
Okay, sir.
Is my screen visible?
Yes, sir. Visible, sir.
So you can just try to solve these two questions. I'll be back in
Okay,
5 minutes.
sir.
All right.
Okay, sir. Okay, sir.
Have you solved it?
No, sir, trying, sir. Up to 50%, sir. First problem, sir, I solved for up to then wide ratio and some and gamma saturated calculated, sir.
Okay.
Then next formula, I think effective stress equal to depth into this gamma dash, sir, saturated, sir. But they are given 50 kilopascals. There, I'm getting confused, sir. Can explain me, sir.
Okay. So this part I have solved earlier.
Yes,
So
sir.
you can go through this. Once it is uploaded, you can go through the link.
Link, sir. Okay, sir.
Yeah. So
Okay, sir.
can you try to solve the second question?
Second, now I will trying, sir. It will
Yeah.
take some time, sir.
Yeah. You can try it.
Yes, sir.
You able to solve?
One question I am going to present the first one.
Okay.
We are going to present some little bit complicated.
You can try for some more time, another three,
Okay, then.
5 minutes.
First
Uh,
one is sir 80.57 km, sir.
for what?
Effective stress at 3 meter below the ground level, sir.
Okay.
50 plus 320, 80.57 comes, sir. Second one, I am going to give in data, sir. And like that, I will solve this ABCD is also, sir.
Okay.
No problem, sir.
Yeah.
Yes, sir. This is effective test pour water. Effective test total test minus pour water pressure, sir. So total pressure minus pour water pressure. This there's a formula we are applying, sir. This one also, sir. This also already solved, sir. In
Yeah,
their
I have solved
portal.
it. I have solved it earlier, but relatively this is a
Yes, sir.
uh, relatively this is an easier question. So you can try for another 5 minutes, and if you are unable to up to 6:30, you can try. And if you are unable to solve,
Okay, sir.
we will move to next for further questions, and you can watch the videos for your clarity. All right?
Okay, sir. Okay,
Yeah,
sir.
you can try
Great, sir.
now. Are you able to solve?
Yes, sir. Yes, sir.
How much? How much? How many subparts were you able to solve?
Sir, A, B, C, D. Up to E, I came, sir. D, I am solving, sir.
Okay.
1 meter. So, sir, explain me, sir. No problem, sir. I am checking with my answer, sir. First one is
No, that no, no,
82.5.
that no, that part I have already covered in the recordings. You can go through after that.
Sir. Okay, sir. First one is first one, sir. I'm telling, sir. First one is 80.57 km, sir.
Okay.
Then 6 meter and 16 to 9.1, 29.43 km, sir.
Okay.
Next one is C, third part. Total plus 6 meter below the ground level, it comes 50 plus 16 to 170 kilo Pascal came, sir.
Okay.
Fourth one is Z into power 1 minute, sir. That's the fourth one now 12 into 9.81. Sir, 9. 117.72 kilopascal came, sir.
Okay.
Fourth one 1 minute, sir. This yard 50, sir. 1 meter. 12 meter into this is 20 as given into 20 240 plus 50, sir. 290 kilopascal came, sir. E, sir.
Okay. So you can check
Okay,
with
sir. Plus,
the things which we have already solved once in the recording. So
G, sir.
in the interest of time, we will move ahead. Right?
Okay, sir. 117, G, sir. Okay, sir. 172 last one, sir. 172.28. Okay, sir.
Right. So now coming to this question, select the desired objectives of compaction. Option A,
This is
increasing the
all. This is all, sir. The theory of things, sir. Decreasing permeability, decreasing settlement, sir. Increasing shear strength. All of the above, sir.
so can you explain how compaction achieves these three?
Sir, by compaction, you getting shear strength are increasing, sir. Automatic shear may not develop, sir, after compaction, sir.
Okay.
Permeability, water it is removing the optimum moisture content, it will be gained, sir. Settlement will be decreasing, sir. After MDD, we are getting FDs based on our MDD, sir.
Okay. Good.
I think like that, sir. Okay, any wrong way explain me, sir. No problem, sir.
Yeah, so ultimately, the compaction is going to reduce the amount of voids that is present, and
Oh, I saw this, sir.
the grain to grain contact is going to increase, which will ultimately contribute to the increase in shear strength. And since the voids
Yes, sir.
ratio is decreasing, the permeability is also going to decrease as
Yes, sir.
the the number of voids is getting less, and
Yes,
decreasing
sir.
settlement. In the sense it can be of both ways. Compaction ultimately it stiffens the soils, which decreases its compressibility, and hence it is going to even the immediate settlement is going to be minimal for perfectly compacted soil or a well compacted soil. Right. So as
Yes,
you
sir.
rightly mentioned, the desired objectives of compaction are all three, all ABC.
Okay. Sir.
All right. Now coming to the
Yes, sir.
next question. So if WOMC Proctor and Gamma Dry Proctor and water content, optimal water content of modified Proctor and Gamma Dry of modified represents the maximum dry densities and optimum moisture contents obtained by performing Proctor and modified Proctor tests. What is the correct relation between these parameters? Are you able to understand the question?
Oh, reading, sir. Comma drive proctor, comma maximum drive density. Little bit confusing, sir. Explain me, sir. Then I will study, sir.
So there are four parameters here you should understand.
Yes, sir.
So just a minute. There are four parameters. So
Yes, sir.
one is two broader parameters, which is optimum moisture content and maximum dry density, right?
Yes, sir.
So that two parameters are given for both the Proctor tests. One is standard Proctor and second is modified Proctor.
Ah, sir.
Okay,
Standard
so
format.
now let us plot the compaction curve for each one. So what is the x-axis? It's going to be gamma,
Gamma D, sir.
and y-axis is
OMC.
going to be
OMC.
moisture content.
Moisture content. OMC.
So let us
What
consider
one?
now this is the compaction curve. So it's not a smooth curve, it's not a, which is usually a smooth curve. So this is going to be WOMC, right?
OMC, sir. OMC, yes, sir.
So this is for
WM.
standard,
Yes, sir.
standard Proctor. And this is going to be
MDD.
MDD for
Standard, sir.
standard Proctor,
Yes, sir.
right?
Great, sir.
Now, what happens if we use modified Proctor? How the curve will shift? So what is the difference between the standard Proctor and modified Proctor test?
Yes, sir.
Just say conceptually, what is the difference between standard and modified Proctor tests? The difference is the number of blows and the number of layers, right?
Yes, sir. Sir. Okay, sir. 25 blows in standard, sir. But modified.
Modified will be 55 blows, or it will be 25 blows for 5 layers. So
As a layers increasing, sir. Yes,
layers
sir. Yes,
is
sir.
increasing, right?
Yes,
So
sir. Okay, sir.
now once the number of layers is increasing, so for the modified compaction, it will shift to top left part. All right.
Sir. Yeah, sir.
So what happens to the maximum dry density and water content?
MDT will getting high, sir, and OMC also getting high, sir.
MDD is
OMC
getting
getting reduced, sir.
reduced, yeah, and
Yes,
MDD
sir.
is
So OMC get reduced, and MDT will getting high, sir.
high, right? So,
Yes, sir.
what will be the correct relation among these four options? So these options gives you the comparison between optimum moisture content and dry density, right? So coming to the what about optimum moisture content, which is more? Optimum moisture content of fractal compaction is going to be higher, right?
Sir, sir.
So we can eliminate option B and option D. Understood. So here it
Yes, sir.
specifies modified Proctor optimum moisture content is higher, right? So
Yes,
the
sir.
options which we are left with is A and C. In this now
See.
coming to the dry density, the dry density of modified Proctor is going to be more, right? than Proctor compaction.
Okay.
So this option is wrong. So the correct option is option C.
See. Okay, sir.
All right. Coming to the next question,
Sir.
match the following. Dry of optimum, wet of optimum. That is the two initial condition. So where dry of optimum is used, where is wet of optimum is used, and what is its characteristics to stresses. How will you analyze this? So dry of optimum will result in dry of optimum is usually used in embankments, and wet of optimum is usually used in core of the dam because of the permeability characteristics. Wet of optimum will have relatively lower permeability compared to dry of optimum. Alright. Now coming to this part. So when you plot stress versus voids ratio, so usually how it varies is that this is how it varies. Sorry. This is how it varies. And when you go to higher stresses, it comes like this. Right. Now let us bifurcate these two. This is dry and this is wet. This is lower stresses and this is higher stresses. Right. Now coming to two options are given. Less deformation at low stresses. Less deformation at low stresses. So deformation can be analyzed by change in voids ratio, right? So at lower stresses, which is having lesser deformation, dry is having lesser deformation, right? Are you able to understand? Hello? Am I audible?
Yes, sir.
So the dry of optimum is having lesser deformation compared to wet of optimum. So
Yes, sir.
dry of optimum is lesser deformation at lower stresses.
Mention low stress.
Lesser deformation at higher stresses is wet of optimum. So the correct match would be A, J, X. Second will be B,
B.
I, Y. Any doubts?
No, sir. Okay, sir.
Right. Now coming to the next question. What will happen to the capillarity if the soil is compacted more? What will happen to capillary rise?
Automatically, sir, capillary, if soil is compacted more, whites will getting less, sir.
Okay.
So that it will increase, yes, sir. I think, sir.
What is the relation between capillary rise and voids ratio or particle size unit, etc.? H is inversely proportional to
Right.
E into
Gamma
D10.
D to DF. Oh,
E
yes,
is
sir.
Void's ratio, D10 is the 10% passing particles, right? So
40%. D10.
E D10 is there, Hc is here. So now once E is getting reduced, Hc is going to increase. So by compaction, compaction is going to reduce E, which in turn is going to increase Hc, right? So
Yes, sir.
the right option is option B.
Yes, sir.
Doubts?
Yes, sir.
Now coming to this question, a soil sample compacted according to standard Proctor test has a density of 2.06 gram per centimeter cube at 100% compaction and at OMC of 14%. What is the dry unit weight? What will be the dry unit weight at zero air voids? If the voids become filled with water, what will be the saturated unit weight? How will you calculate this? What are all the given? First, we list down the given parameters, right?
Yes, sir.
Now we have
Density
gamma bulk
2.06. Yes, sir. OMC
2.06 gram
14%.
per
GS
cc.
2.67.
Water content is
14%.
0.14,
1.4 on.
right? So now at 100% compaction. So what is the dry unit weight? So how will you calculate dry unit weight? Gamma dry is equal to
1 plus
uh, gamma bulk by
bulk density divided by 1 plus C, sir.
1 plus W. How much you are getting?
W. 2.06 plus 1 by 0.
Will be 1.87.
1.807. 1.807, sir.
You are getting? Let us round it up to 1.81.
81, sir. Yes.
1 gram per cc. So that part you have found out. Now, moving to this, what will be the dry unit weight at zero air voids? How will you calculate this?
0 adverse, sir. Specific gravity into weight of water, sir.
Yeah, how will you calculate it? Will be calculated gamma
G.
dry is equal to gamma W G divided by
Yes.
1 plus
1 plus W into GS.
W into G
Yes, sir.
by S.
Yes, sir. Saturated with
So zero air voids in the sense it is completely
saturated one equal
saturated
to 1 we will take,
equal
sir.
to
Yes,
1.
sir.
So how much you are
Yes, sir.
getting?
2.67 divided by 1 plus 0.14 into 2.6 1.7. 2.67 divided by 1.943, sir.
So we will round it up to
1.95.
1.14 gram per cc.
Yes, yes, sir.
Right. Now,
Right.
if the voids become filled with water, what would be the saturated unit? Right.
No.
So we need uh, gamma sat equal to total weight by total volume. All right. So
Yes, sir.
now gamma dry is going to be weight of solids by total volume, right? So let us
Yes, sir.
consider volume is 1 cc, right?
Yes, sir.
So weight of solids is going to be 1.81 grams, all right?
Yes, sir.
Understood.
Understood, sir.
And the water content, what we got is 0.14, right?
Yes, sir.
Which is going to be weight of water by weight of solids. So how
Sure,
much will
college.
be the weight of water? Weight of water is going to be 1.81 into
Point.
0.14.
Yes, sir.
How much you are getting?
0.253, sir.
Getting 0.253 grams.
Sure.
That is the amount of water that is present.
Yes, sir.
So when we multiply it with um, what to say um, unit weight, we will get volume of water occupied is 0.253
2.3.
cc.
Yes,
Right? Understood.
sir. Understood.
Now we need to understand what is the volume of solids that is present. So volume
This
of
one.
solids will get gamma S is equal to weight of solids by gamma of volume of solids, right?
Yes,
So
sir.
volume of solids is equal to weight of solids is 1.81
Two.
divided by gamma W is 1 into G. It's 2.67. How much you are getting?
0.677, sir.
Point
677.
six
668 with the road.
six seven
8. 7.
grams or 6.8 you can write.
678, sir.
0.68 grams. Alright. So we know the volume of solids that is present, volume of voids is present. We know volume of water that needs to be added, right?
Yes, sir.
0.68 and the volume of water that needs to be added, the volume of voids is going to be 0.32, right?
Yes, sir.
Understood?
Understood, sir.
Sorry, this is going to be CC, right? CC. So from 1 cc, volume of voids is going to be 0.32
3 to
cc,
come.
which is going to be equal to volume of water, right?
Yes, sir.
Now, so the total, what to put it? Total weight equal to weight of solids plus weight of water.
One.
This is going to be 0.32 grams. Understood?
Yes, sir.
Uh, weight of solids is we know already 1.81 grams plus 0.32 grams. The total volume which we have is
2.13, sir.
1 cc, right? For total
Oh, one,
volume
sir.
is 1 cc. How much you are getting?
2.13, sir.
2.13 gram per See,
See,
this is the saturated unit heat which we get
yes,
when
sir.
the all the voids are filled with water.
Yes,
Right?
sir.
Now coming to the any doubts?
No, sir. Okay, sir.
Now coming to the second question in this page, a bell-shaped proper compaction curve implies which kind of grading for a given soil. So bell-shaped compaction curve is going to be perfect compaction curve, right?
Yes, sir.
Gamma D and water content. This is a perfect bell-shaped curve. So for what type of soil we get this perfect curve?
Well graded soil only, sir. मतलब less like blanketing, well-graded soil, all particles will, voids will fill, sir, during compaction.
Yeah,
So that well-graded soil is suitable for shaped potted, sir.
you are right.
Bell-shaped
So
potted, sir. Yes, sir.
well-graded soil is the one which we go
Suitable, sir.
for perfect well-graded,
Yes, sir.
well-graded, sorry, perfect well-shaped curve. All right.
Yes, sir.
So, so with this, we will stop for this week
Yes,
today.
sir.
All right.
Yes, sir.
So
Yes,
it's
sir.
almost going to be 7. So we will
Yes, sir.
stop for this week today. We will continue the remaining questions in the next week.
Yes, sir.
And meanwhile, you can go through the videos, recording of the videos in the links which will be shared with you, and also the
Yes, sir.
slides of the questions. You can also, these slides will be shared with you, so you can also try solving it by yourself. All right.
Yes, sir.
So,
Okay.
and as a concluding remark, these sessions will be conducted on Saturdays 5 p.m. to 7 p.m. till the running of the course. And
Yes,
as
sir.
a prerequisite, I request the learners to watch the lectures of that particular week and attend this session to have a good clarity of concepts so that you can apply it in a better way while solving the problems. All right.
Okay, sir. All right, sir. Thank you,
So
sir.
with this, we will stop the session. Thank you.
Yes, sir. Okay, sir. Okay, sir. Thank you, sir. Thank you, sir. Okay, sir.